Okay, what we're going to do is we will be solving exponential equations using the one-to-one property. The one-to-one property says that if 2 to the a equals 2 to the b, then a equals b. And this follows from the fact that y equals 2 to the x is a one-to-one function. One-to-one means if the output of the function are equal, then the input have to be equal. So let's go ahead and do some examples where we solve for x when we have an exponential equation. Now, we can't always use this property. Let's just solve a couple and then I'll talk about when we can use that property and when we cannot. So in this problem right here, we have 2 raised to the x minus 1 and on the left and 2 raised to the 2x minus 4 on the right. So they have the same base. So these exponents have the same base. And that's what we need if we want to use the one-to-one property. So then that becomes x minus 1 equals 2x minus 4. And then you solve this linear equation whatever way you want. I can subtract x from both sides, add 4 to both sides. And you could check your answer by plugging in if you feel that you need to. But, you know, I mean, you don't always have to check by writing it out. You could just do it in your head. Okay, so you could, you can just do that in your head. If maybe just check it in your head. So here's another one. This is base 3. Again, we have the same base, so then we set those things up there, those exponents equal to each other. And there you go. Okay, so there's another type of problem that we can look at, which is just a little bit different, but not that different. And that is a problem where we have 2 different bases to start off with. Okay, so here the bases aren't equal. Hold on, is that an n? Yes, not equal, but 8 is equal to 2 to the 3rd power, 16 is equal to 2 to the 4th. So I'm just using times tables. There is a little bit of something I have to be careful about. I need to use parentheses really liberally to get this to work properly. And then I have to remember that if you just have x to the m raised to the n power, this is x to the m times n. That's what happens when you raise exponents. Okay, so here I have 2 to the 3 times x plus 2 equals 2 to the 4 x plus 1. And then I let 3 times x plus 2 equals 4 times x plus 1. And then I'll distribute on both sides and then solve and there we go, and we can check that if we want by plugging in. So the key is we need to get to a point where I have the same base. If I can't get to that point, then we have another way to do that, but maybe it's a little more involved, but we'll talk about that also. Okay, so note that 25 is equal to 5 squared. So here we have different bases. It's not really a new type of problem. It's the same type of problem, but we're just doing more of the same there, where I'm writing 25 as 5 squared, and then I will distribute the 2, right? 4x plus 4. And now we have the same base. And because they're the same base, I'll have 2x equals 4x plus 4. And then I can solve this. The thing is, I don't like really showing all my work when I have a linear problem sometimes, because when I show more work, it looks very messy, and actually I might get it wrong because of that. So, but you can always check, plug in wherever you want along the way. This one's a little bit different. Suppose I have 5 to the x equals square root of 5. I like this because it just helps us to practice this idea that the square root of 5 is the same thing as 5 to the 1/2 power. Okay, that's all.